Hydroplot is a graphical tool used to visualize the results of different HELIOS runs. It has the ability to plot a very large range of different plasma properties. One such property can be found in the Time tab here. In this tab, we can select Zone Boundary Positions, where we can see how the zones of our foil evolve as a function of time. Here, each line represents a different zone boundary as it evolves as the foil is heated. We can see at earlier times all of the zone boundaries are uniform and together. This is the case of the initial foil. As the foil is heated with the short pulse laser, we can see the outer boundaries begin to oblate and dissipate away. Interestingly, we can actually see some physics going on within the foil in this plot. If we zoom into earlier times, we can actually see a shock wave here. This shock wave is produced when the outer boundary zones oblate and pressure builds up within the foil itself. Another interesting visualization can also be found in this Time tab. Here we can click the energetics option and look at different time integrated options. Here, the total laser energy will be the total laser energy deposited into the foil as a function of time. Here, we can see the time integrated energy profile of the energy from the laser being dissipated into the foil. This rise here corresponds to the time where the pulse is hitting the foil. We see at earlier times only a little bit of energy is being deposited in. This is due to the Gaussian nature of our short pulse laser. The peak of the pulse happens when the slope of this incline is at its steepest in the center. Finally, as time goes on, we see the slope begin to decrease, and this is due to the tail end of our Gaussian profile. And then at later times, we see a plateau. This is after the laser has completely fired, and there's no longer any energy going into the system. We can also take a look at the energy being lost by the system through radiation. To do that, we go back to this Energetics tab and choose Radiation at Boundary. Here, we can see a curve that's the time integration of the energy lost due to radiation from the foil. We again see the initial rise from the laser hitting the foil, but unlike the previous plot, we never really see a full plateau. That's because the foil continues to radiate even after the laser has finished firing. It can also be insightful to take a look at different plasma properties as a function of space. To do this, we go back to our Spatial Profile tab, and we see a list of different plasma properties we can take a look at. For now, let's just choose electron temperature, and then we can choose several time steps to take a look at. Here, we can see different electron temperature curves at different times across the radius of our foil. We can also choose to animate this a little bit. To do that, we go back to our main menu, we choose Cycle with Step Size, and Plot. Here, we can hold down the Up key and look at different distributions at different times as we're stepping through them all to get a more clear understanding of how the system is changing with time and space. One thing that you can notice stepping through all the time steps like this is that the radial range is kind of constantly changing. So one way that we can take a look at evolving plasma properties as a function of space while making it more uniform to look at is to go back to Hydroplot and choose Zone Index instead of Radius. Now, when we choose to plot it, we see an initial time step. All of the zones are listed. Now, when we step through time, we see the range is consistent, so it offers a much more compact way at seeing how the system is evolving. Finally, let's take a look at a contour plot. To do this, we go back to the Hydroplot main window and choose Contour here. There's a lot of different variables to look at, but for this case, let's just take a look at electron temperature. Our x-axis will be the spatial radius, and our y-axis will be time. In the contour plot produced, we can see some interesting characteristics of our system. We see at earlier times, our foil is nice and uniform and room temperature, and then as time goes on, the outer surface of the foil is hit by the short pulse laser, which leads to ablation. This expansion is an adiabatic process, so we see the system begins to thermally cool back down to room temperature. And that brings us to the end of our Hydroplot demonstration video. If you have any questions or would like to request a demo, feel free to come to our website and use any of the contacts here to reach out to us. Thanks for watching.